Hey guys, welcome back. We continue with the book Automate the Boring Stuff with Python, and in this video we're gonna cover chapter 9, Reading and Writing Files. You can follow along for free by heading over to automatetheboringstuff.com. The link is also in the description down below, and if you prefer a physical copy of the book, you will find a link in the description down below as well. Now in the previous videos we already worked with variables and we learned how we can store data in variables. The problem is that the data is being lost once we stop executing the program and we restart it, and we really need a way to persist our data. And one way to do that is to read and write files that are stored on our hard drive. Now depending on whether you're working on Windows, macOS or Linux, the file structure is going to look slightly differently, but typically it looks something like this. At least on Windows we have a directory, for example C. Then inside of that we have a folder, for example users, inside of which we have other folders or directories. And then of course inside of that structure we're going to have some kind of file, for example a Word file. Now there are some differences between the operating systems. For example in Windows, when we navigate to certain paths in our directory structure, we are going to be using backslashes in between the different folder names. In macOS and Linux we instead use a forward slash. But fortunately we can use a module that Python provides which takes care of that for us and covers those differences between different operating systems. Specifically we can use the path function, which is part of the pathlib Python module, which we can import. And when we call the path function and pass different file or folder names to it, we're gonna get back the specific path. Now typically we're using the plus operator when we want to concatenate certain items, for example two strings that we want to combine. When we are working with directories and path, we can instead use a forward slash. We're using a function call to path, and then we use a forward slash and we pass in additional values that should be combined. And as we run this, we can see we basically construct this kind of directory structure, basically adding together those different directories. Now every program that runs on our computer has a current working directory, and any file names or paths that do not begin with the root folder are assumed to be under the current working directory. And we can get the current working directory by using the cwd function, which we call on the path object here. So we need to first, of course, import path. We also import the os module, and then if we take a look at path.cwd, we get back the current working directory. We can also use the pathlib module to reference our home directory by calling path.home, and that's gonna give us back the home directory from which we are working. And since our scripts are almost certainly going to have permissions to read and write files under our home directory, it's an ideal place to put the files that our Python program will work with. Now when we're working with paths, there are basically two ways to specify a file path. We can either use an absolute path, which always begins with a root folder, or we can use a relative path, which is relative to the program's current working directory. So here we see some examples of relative path and absolute path, depending on what our current working directory is, so in which directory we're basically in. The relative path will be different. So for instance, if we are inside of this bacon directory here, if we want to take a look at the fizz directory, we would write ./fizz. And then if we want to go up one directory, we would basically put in 2 dots. And this is going to move us up one directory. The absolute path on the other side will always start from the root directory. So in this case here from C. So if we want to head over to fizz, for instance, we would always start our navigation from the root directory, then head over to bacon, and then head over to fizz. Alright guys, switching over to Windows, we can create new folders using a specific function. For that we have to import the os module, and then we can call makedirs, and we pass in the path that we want to use. So here under Windows we can, for example, pass in C, delicious, walnut, waffles, and this is the directory we're going to create. So switching over to the Explorer, we can see that indeed we created that folder structure here, delicious, walnut, and then the directory waffles inside of it. We can also create a directory from the path object, and for that we can use the make directory method here. So for that we need to first import path from the module parselib. Then we can call parse and enter the specific path we want to create, and then we type in make directory. We can also use the parselib module to check whether a given path is an absolute path, and then returning the absolute path of a relative path. So first of all, we can type in path.cwd for the current working directory, and then we can check whether this is an absolute path by typing in is absolute after the current working directory, and here we're gonna get back true. But if instead we are using a relative path like this, and we're checking whether it's absolute, we're gonna get back false, because of course that's a relative and not an absolute path. If you want to get an absolute path from a relative path, what we can do is we can put path.cwd in front of our relative path, separated by a slash character, and that's gonna give us back the absolute path. And the path module has a couple of useful functions related to absolute and relative paths. So for instance, we can use a method to return a string of the absolute path of the argument. To do that, we can do the following. We can type in os.path.abs path and then the specific path, and that's going to give us back the absolute path of the argument. We can also use the isAbs function, which is going to return true if the argument is an absolute path and false if it's a relative path. So in this case here we are working with the relative path. And we can also use the relPath function, which will return a string of a relative path from the start path to path. And if the start path is not provided, then the current working directory is used in the start path. Now if you look back at our file structure, when we have a path object, we can extract the different parts of our file path programmatically. So let's first have a quick look at the different parts of a file path. We have first the anchor, which is the root folder of the file system. Then on Windows we have the drive, which is a single letter that often refers to the physical hard drive or other storage devices. Then we have the parent, which is the folder that contains the file we are looking at. And then of course we have the name of the file. And the name of the file is made up of the stem and then the suffix, which denotes what kind of file type it is. So let's have a look at how we can work with that, working with the directory and file that we created before. So here we are using our path call to get the spam file that we created before, and we are referencing that in the variable p. Now once we have done that, we can go ahead and we can type in p.anchor, and that's going to give us back the anchor of our file path, so in this case here c:\\\. We can then also get back the name of the file, which gives us back spam.txt. And of course we can also have a look at the parent, which is of course the folder structure all the way up to the file itself. And if we take a closer look at the file name itself, we can differentiate it by stem, which is the first part of spam.txt. And then we can also have a look at the suffix, which of course for a text file will be .txt. And finally, let's have a look at the drive, which in this case is of course C. Now if we take a closer look at the parent object, we already saw that this is going to be the folder structure to the file that we are looking at. So in this case, C uses Robin. We also have the option to basically split up the different parents here a little bit more. So we can use the function parents here. And if we type in 0, that's going to refer to the current location. So that's basically the directory where the file is located in. But we could, for instance, go one level up, which is gonna give us back C users. And we could go up even higher to have a look at C, for instance. We can also have a look whether a certain file path exists or not. So for example, here we have a not exist directory path, which we store in the variable not exist dir. And if we call exists on it, we're gonna get back whether that file path actually exists or not. And of course here we're gonna get back false. If instead we take our Windows directory from before, which of course is valid, and we call exists on it, then we get back true. And this is an easy way to check whether a path actually exists or not. Now that we are comfortable working with folders and relative paths, we are able to specify the location of files to read and write them. And we're going to start out with plain text files, so regular text files that do not include additional information such as font, size or color information. And an example of that, for example, is a txt file that we have seen before. Those plain text files are different from, for instance, binary files such as PDF documents, images, spreadsheets, and so on and so forth. They include additional information and we are going to ignore them for now. So let's have a look at how we can read and write text. For this we are again going to import path from the Shelve module. Then we're going to get the path for spam.txt and setting it to the variable p. And now we can write some text to it, for example hello world, which we do by calling the write text function. And we get back the number 13, which indicates that we wrote 13 characters to that text file. Now to read the text later on, we can just call read text, and then we're going to get back the text that we wrote before. Now the parse object methods that we used so far only provide basic interactions with files. Typically we're going to use a slightly different approach. Typically we are going to use the open function and work with different file objects. And for that we have 3 different steps of reading and writing files in Python. We would first call the open function to return a file object. Then we would call the read or write method on the file object. And then finally we always need to close the file by calling close on the file object. Now let's open a file using the open method. And for that we're gonna head over to our users folder. And when we select our user, inside of that directory we can create a new text file and call it hello.txt. And then we can type in some content, for example hello world, and save this file. And now we can go ahead and call the open method here. We pass in the home path and then slash hello.txt, and we're gonna store that in our variable hello file. Now once we've done that, we can call the read function here on our hello file, and what we get back here is going to be saved in hello content. And now if you take a look at hello content, we can see that indeed we get back hello world, which is of course exactly the content we provided inside of the text file. Now the read method that we used before is always going to return a single string value. If you have a very long text, we may want to prefer to actually get back individual lines of text, and for that we can use the readlines method. And the readlines method is going to get us back a list of string values from the file, and each line inside of that file will be a separate string inside of that list. So let's have a look at an example. We can create a new text file in the same directory as before, and here we have 4 lines of text included in this text file, sonnet29.txt. And just as before, we are going to open that file and assign it to a variable. And then rather than using read, we are going to use read lines on this file. And if we have a look at that, we can see we get back a list, so not a single string, but a list of strings. And each of those lines is its own separate string. Now we can also write to files, not just read them. And when we write to files, there are 2 different modes that we typically work with, either the write mode or the append mode. And the write mode is just going to overwrite whatever is inside of that text file, so we would use it when we create a new text file, for instance. The append mode, on the other hand, is always going to append text to the end of the text file, so we can use it to add something to an existing text file that we're working with. And whenever we open a file, we would indicate whether we want to write to it or append to it. So in this case here we have a new file that we want to work with called bacon.txt, and we are going to open it in write mode, which basically creates this file. We are then going to write some text to it using the write method here. So in this case we're adding hello world. We get back of course the number of characters of that string that we provided as the content. And then we need to make sure that we actually close our file. That's always the last step we are taking. Now if we later on want to append something to our file, we can again call open. We would pass in the file that we want to add something to, and we are passing a as a second parameter to append something to our existing file. Now we can use the write method again to write some additional text to our file. Again, we get back the size of what we added, and let's close our file again now that we finished that operation. Now if you want to have a look at the entire content of the file, we can call open again with the name of the text file as the argument, and we are going to extract the content of this file by calling read on it and assigning that to the content variable. Now again we need to close our file as before, and then finally we can print out the content. And this is going to give us back the entire content of our file, so the initial line that we created when we created the file, hello world, and then the second line that we appended, this particular line here. Now if we want to save binary files for later access, we can use the Shelve module. The Shelve module allows us to save data in a variable, and then to later on access this variable even after we ended the program and restarted it. So let's have a quick look at an example. We first need to import the Shelve module in order to use it, and then we can store the data under a certain name by calling open on Shelve and passing the name under which we want to save this. In this case, we are going to assign that to the Shelve file. After that, we can take a variable, for example, in this case, a list of different entries, and we can assign that to Shelve file here by providing a key under which that should be stored. And once we have done that, we have to close the file just as we did before. Now, if we want to read the data again, we can open that Shelve file again, and we can have a look at the type. So here we see it's a database file. And now we can reference the key we stored before, for example, cats in this case, to access the data we stored. So in this case, a list with those 3 different entries. So this gives us an easy way to store some values. And then of course, once we've done that, we need to close that file again, just as we did before. So in general, if we want to work with plain text files, regular text files, for example, we can use the process we learned about before using the open, read, or read lines and then the close method. But if we want to save data from our Python programs, then we would use the Shelve module. Let's have a look at a practice project. We are going to generate a random quiz that asks a bunch of different questions. And let's assume we want to use it as a test for students. In order to ensure that students cannot cheat, we want to shuffle the questions around so that they do have a different order each time. So what we're going to do is we are going to create 35 different quizzes, which have 50 multiple choice questions. And to do that, of course, we are going to use what we learned so far. So let's head over to our editor and let's have a look. Since we want to randomly shuffle the different questions, we are going to need to import the random module. And then we have a list of different capitals for different states. And we're going to turn that into a list. And then we are going to generate our 35 quiz files for the different students. We are going to open the new file and also the answer key file. And then we're going to write the name, date, and the period, which should be filled out by the respective student. Then we shuffle the order of the states by getting the keys from our capitals dictionary here and using the shuffle method, which is part of the random module. After that, we loop through all 50 states, making a question for each. And as we do that, of course, we are going to use the write method to write the question and also the question number. And we're also going to write out the answer key to a file. At the end, of course, we need to ensure that we close both the quiz file and also the answer key file. Now with that in place, let's run our program. So there's nothing visible here, but in the folder where we actually wrote this program here, we now have a number of different files. And if we just take a look at one of them, we can see we get this overview back. So we have here the name, date, and period, the heading, and then we have the 50 different questions in a random order. So that's how we can use what you learned so far to generate quiz files. Let's have a look at the practice questions. The first one is, what is a relative path relative to? So relative paths, other than absolute paths, are relative to the current working directory that we are in. What does an absolute path start with? So the absolute path always starts from the root folder. So for example, if you work on Windows with C:/, or if you're on a different operating system, for example on Mac OS, we would start with / for the root directory. What does path C users /L evaluate to on Windows? So on Windows, it will evaluate to C:/users/L. So it's basically just adding this additional directory here, but that can behave differently with other operating systems. What does C:/users/L evaluate to on Windows? So that will actually lead to an error because we can't use the / operator to join two strings together. What does os.getCWD and os.chdr functions do? So the first one, getCWD, will get us back the current working directory that we are in, and chdr changes the current working directory. So what are the dot and .. folders? So the dot will always refer to the current directory that we are in, and ... refers to the parent directory. In C, bacon, x, spam.txt, which part is the directory name and which part is the base name. So the directory name is basically anything up to but not including the file itself, and spam.txt is the base name. What are the three mode arguments that can be passed to the open function? So here we can use R for opening a file in read mode, W to open it in write mode, or A to open it in append mode. What happens if an existing file is opened in write mode? So in that case we are going to overwrite anything that's inside of the file, so anything in that file will be replaced and by whatever we pass in. If instead we want to add to the file, we would have to use the append mode instead. What is the difference between the read and read lines methods? So the read method is going to return the file's content as a single string, while read lines is going to return a list of strings and each individual line will be a separate string. What data structure does a shelf value resemble? So shelf value is basically a dictionary value. It has keys and values and it works similarly to dictionaries. But of course we can access those shelf values even after we end the program and restart it and thereby still access it. So in this video we learned how to work with files, how to open files, read files and also write our own files. In the next video we are going to cover organizing files. Subscribe to the channel to stay up to date whenever a new video is released and see you guys in the next video.